So what other kind of data do we need to collect here? So we know that we found a colony of fiddlers, and we also know that it's the biggest colony we found, so we'll put that in our comments in our data sheet. We've noted the latitude and the longitude of the location, and now we have to test the soil for its strength. So we're going to use the penetrometer, and I'm going to have Mr. Lacey do this. Okay. So there's a line right here, Mr. Lacey. You just put this in the mud and you sink it down to that line. When it stops there, it will give you an indication how strong the mud is on the top. What you doing, Mr. Lacey?
So right here I have this thing called a refractometer. It is a tool that scientists use in the field when they're outside doing research, and it measures the salinity of water. Salinity basically means the saltiness of the water. So before we actually test the water here, I'm gonna kind of clean it off with some fresh water. And basically there's this little, I don't actually know what it's even called, a little trap door, a little flap that covers the area that measures the salt levels.
Stage, yep. So pour that fresh water right on the stage
pour
there.
Right on there. Shake it off a little. And that kind of almost like resets. Before that, I'm going to test it to see what the salinity of the fresh water is.
So this is called a control. We want to make sure that our instrument is reading correctly. What do you suppose the salinity of fresh water should be in parts per thousand from 0 to 1,000?
You're asking me, eh?
Well, I was asking the class, but what do you got there?
It is at 0.
Does that make sense? 0 salt in fresh water?
Makes sense to me.
And it must be calibrated. If it's right at 0, it's giving you a true reading. Because
fresh
water should...
Basically, just so you guys can know what I'm doing, I'm kind of like holding this thing that looks like a little telescope. I'm holding it up to the light, and I can see there's a scale in there, and it's blue and white, and there's numbers, and the blue level comes down to 0 on the right-hand side of it, and it has this little symbol that almost looks like a percentage symbol with an extra circle on it. So that's parts per thousand. So yeah, we're at 0.
We're going to be able to do some of this out in the schoolyard, use refractometers, so you guys can try them out.
Courtyard. All right, Mr. Reynolds is the more rugged one. You'll know that when you get to know us. He's climbing down in the mud because he has his shoes that it actually makes sense of going in the water here. And he just dipped the refractometer down in the water, collected a water sample.
And hold it up to the light, and the amount of salt that's in the water bends the light differently, and that makes a different reading on the meter. So this meter
it refracts it, right?
It refracts it, exactly.
I wonder how they got the name refractometer.
Just a series of lenses through here that bend it. So anyway, I'm looking at 32 parts per thousand, which is the same salinity as the ocean water, right? Out in front of the beach. So that tells us something about this creek, that it's entirely fed by the tide. There's no fresh water really pouring in here other than perhaps groundwater coming off the forest. But inside the creek, we're looking at water as salty as the open ocean. And we know that the fiddlers do require salt in their water. I'm not sure what the exact percentage, the threshold is, but they do require some salt. It would be interesting to find out.
So Mr. Reynolds and I were just noticing there's even more burrows over across the way there, and that brought me to a question actually that I don't think we've answered, and that is how did the fiddler crabs actually get here if they weren't originally here?
Okay, well, quite often in the case of invasive species, they're introduced to a new environment with the help of man. For example, the Phragmites grass that we're going to be studying later was brought here in the 1800s by someone who wanted to have tall grass as a wall around their yard. It was brought from the southern hemisphere. Now it's in 48 states and it's a complete invasive. With the case of these crabs, however, man did not bring the crabs here. The Gulf Stream brought them here. The Gulf Stream is this river of water that flows up the east coast, the Gulf of Mexico, and it goes all the way to Cape Cod, and then it shoots over to Europe. And as far as recorded history goes, the fiddler crabs never made it up above Cape Cod. They never really took hold here in what we call the Gulf of Maine. And that's because the water temperatures were always too cold in the winter. So their larvae, which is part of their life cycle, it has to overwinter in the water. And if the water temperature gets below 40 degrees Fahrenheit, I should know what that is in Celsius, but I don't, the larvae dies if it's under 40 degrees for an extended period. dies. If it's under 40 degrees for an extended period of time, the larvae can't stand it. So we have to ask ourselves, what's been happening lately that would allow the crab larvae to make it through the winter? What's been going on in the waters of Maine? It's a question maybe you guys can answer to.